For this video, we are consulting the notes linked below the like button, section 16.7, which is in Fourier series, where we look at the RMS value of a periodic function. So first we need to find the average power at our terminals, and then we need the RMS values for voltage and current. We see we have VRMS right here, and VRMS is also interchangeable with IRMS. You find them the same way. So we are going to come back to both of these and look and try to solve them. First, we want our average power. So I'm going to screenshot this and bring this in here. Now, we are going to have to come back to this in a second because we need all of this in cosine. And we can see that this sign and this sign is not a cosine. To convert it from sine to cosine, it's very simple. All we need to do is subtract 90 degrees from it. This is talked about a lot earlier in the playlist linked below the like button with a lot of the early problems that we've done. So we're just going to subtract 90 degrees from this. We can rewrite this as 70 plus 200. We have cosine. Since this is like a steady state, our omega is going to be the same, minus a 45 degrees, because we have a negative 90 plus a 45 degrees, plus we have 60. We're going to have cosine 1500 t. And then we have our volts. And for our volts, after we have this, we're going to do it for our I. It's important to actually label them so you know what you're doing, because that is going to come in very handy so we don't mix anything up. 8 plus 6 cosine. This is just going to be the same. We have our 500t plus the 75 degrees. Then we will have a plus 3 cosine. Then we're going to have 1500t minus the 6. Oh wait, you have a negative 30 and a negative 90, so it's going to be a minus 120 degrees. And then this is in amps, because that is how we measure current. And so now that we have this, we are going to find the average power. We are going to need to add all of these together. Now, for this first part right here, since we don't have any cosine values, we're essentially going to have cosine of 0 minus cosine of 0. Cosine of 0 is 1. We're just going to have our voltage times current divided by 2. And I'll actually just demonstrate this out real quick. So we'll have power average equal to our Imax times Vmax. So that's going to be like 8 times 70. This is going to be divided by 2. And then we have cosine. Our angle is just 0 minus 0 for this. This is just going to give us 1. So we have 8 times 70 over 2. Divide this out. This is going to be 8 times 35 essentially. Now we can solve for the rest of them. And this is just going to be basically saying, well, we have plus, we have our Imax, which is 6, times our Vmax, which is 200, divide this by 2. And then we have cosine of our angle. So we're going to have a negative 45 degrees here. And then, notice, and this is important to notice, and this is why I said the label is very important. You have the angle of our current minus the angle of our voltage. So the angle of our current is 75 degrees minus the angle of our voltage, which is negative 45 degrees. Now we need to add the next part. So we'll have a plus 3 times 60 divided by 2. Then we have cosine of we have negative 120 minus 0. And so for our power average, we are going to get approximately the answer of 215 watts. Now we have, what is the RMS value of the voltage of this truncated circuit? So for our voltage, we can bring back the notes. It's going to look something just like this. We only really need to copy the first part. And so this is the formula that we are going to use. This was for power. You can throw it up there. And now we need to use the VRMS. And remember, VRMS and IRMS are essentially the same thing. So for this, we need our AV squared. Well, our AV squared and our IV squared our AV squared for our IRMS is just going to be the first part right here. So for voltage, which is VRMS, this is going to be equal to the square root. And then inside of here, we are going to have our 70 squared plus, and now we need the summation of the rest of our stuff. So the next value that we have is going to be the 200 divided by our square root of 2, and this is all squared, plus the next thing, which is the 60 over square root of 2, and this is all squared. And then we're going to repeat this for our current. So we have IRMS is equal to the square roots. We have our AV, which is the very first value, that's going to be 8 squared, plus the 6 over the square root of 2 squared, plus, and then we have our 3 over the square root of 2, and this is all squared. And when we plug this into a calculator, we are going to come out with approximately 163 VRMS and 9.3 ARMS. So that is super easy to solve as long as we consult the notes, and that is the theory and how to do this problem.